Ron with OG Matrix here to do a computer build video with you because there's just not enough computer build videos out here on YouTube, are there? So you may be wondering, why another build YouTube video? Why am I doing it? Well, now that you've stumbled upon my video, you see I've got no shelves full of computer components and boxes or a green screen that looks like I got shelves full of computer components and boxes. I'm kind of a first-time builder. I'm a hobbyist. I've just always been good at taking shit apart and putting it back together, figuring it out. Just here to talk about my experience with building my first computer, or doing a full build, my first full build with computer. I've done computer peripherals, done change outs, upgrades to computers for mine and my friends, family over the years, but this is my first full computer build. Why am I making this video? Not to be a YouTube sensation by any means. This is more for, this is a very basic video set here. This is actually going to be about a 3 or 4 part series. This first part here that we're doing today is about picking out your components and how to do that, what to look for, where to look for them, how to do this on a budget, or how to go extreme on it if you want to. So you can look at this as a build video for newbies, noobs, beginners, budget builders, kind of a building guide for dummies. So what do I have to add that you haven't already seen through the other 10, 12, 20 build videos that you have already? Basically here with this, I'm going to try to simplify some things. One of the great things about having experts all over YouTube video is that you learn a lot of in-depth stuff. But a lot of these experts forget what it's like to not know anything at all, to be brand new to this. So what we're going to be going over is some common sense things that the expert, or some things that the experts kind of give to common sense, take for granted that us newbies don't know anything about. We're going to talk about SATA ports, fan headers, part compatibility, used parts versus new parts. That's going to be a big thing that we're going to be doing here today. So this build actually started back in about 2016 indirectly. I had an old Asus desktop that I bought back in 2019, and at the time I bought it, I spent about 500 bucks for it, and for a consumer desktop, it was a great desktop. Asus at the time was only known for their motherboards. And this was their first mid-tower to come to the consumer market. It had what others didn't have at the same price range. It had HDMI output. It had Wi-Fi built into it. It had PCI Express. Regular PCI 1 was out, but the PCI Express, the new generation of it, was just then coming out. Windows 7 64-bit systems were coming out at that time. 32-bit was still really common. But in 2016, whenever Microsoft forced all of us to upgrade to Windows 10, I thought, man, what a great idea. Free upgrade to Windows 10 from Windows 7, wonderful. And then, like so many others, whenever I've installed Windows 10 on there, it crashed my system. Actually, what ended up happening is my hard drive froze up during installation, but I didn't realize that till a couple of years later when I just started digging it out, tried to get, working on it, trying to get it to work again. That's when I figured out that my hard drive was actually froze up on it. Last year, in 2019, I happened to see on Amazon that the hard drives, I could get a 1 terabyte blue hard drive, Western Digital blue hard drive, for about 40 bucks, 45 bucks. So I picked that up, put it in the computer, just fired it right up, and got my Windows back on there, got everything going. And then as I started putting programs on it, everything, I found out and realized that the hardware was so out of date, I could barely run anything on it. So I started looking into what it would take to upgrade it. What I ended up finding out is, even to upgrade this desktop to the max, putting a new processor in it, which was only going to be a quad-core 3 gigahertz processor, to get 4 gigabytes of RAM, which were DDR2 at the time, and to do the max, the highest grade GPU graphics card that I could put in there, it was still going to cost me about 300 bucks. And this is outdated technology. The problem is that whenever technology first comes out, it's very, very expensive. And then as new generations and new technology comes out, those prices drop down. But then when those prices are that technology, those components become quote unquote obsolete, then they start going up and up in price again because they're harder and harder to find for your older units. So to upgrade my piece of crap old PC, 10 years old, was going to cost me 300 bucks. So as I'm looking through videos on how to upgrade my existing computer, I'm running across other videos on how to build your own computer, build your gaming computer, budget builds, this build, that build. And I went down the rabbit hole. And now I'm contributing to the rabbit hole. You're welcome. Now I've got to say, with everything that I did, I've got to give a special thanks to Jay's 2 Cents, Linus Tech Tips. Linus also has a secondary channel called Tech Quickie, which gives little 4 and 5 minute snippet videos on basic stuff, just little quick information, which helped immensely. And also Paul's Hardware. He does a lot of reviews and a lot of builds and stuff. And after I had built my computer, I found a build that he did that he ended up using the same motherboard, same chipset, and everything here. So this here I kind of put together on my own based upon what I learned. And then ended up finding a video from Paul that he ended up using almost all the same components that we're using here in this build. So before we get into the actual components of your PC build, let's talk about where to buy them. Everybody's got Amazon. Everybody's got a Best Buy close to them, I'm sure. However, don't just use that as your only 2 resources for buying your electronics. You can also go through newegg.com. They have been around forever. Extremely reputable company. They've got a lot of great prices. Use them for shopping. We've also got Micro Center. I have one locally. See if you have one locally. If you do, fantastic. They've got a lot of great deals. They also do a lot of bundles. If you buy a motherboard and a CPU together, you get $20 off. If you add a hard drive to that, they'll give you $30 off on a bundle. But most of their stuff is in-store only. So if you don't have one around you, see if you got a friend or a family member that has one close to them, and they can usually, if it's cheaper for them to get it for you and have them ship it to you, go that route. Also, something you're not going to hear hardly anybody else talk about is eBay. And a lot of people are scared away from getting used electronics on eBay. However, some of the components you can get so cheap on eBay that you could actually burn through 2 or 3 of them before you'd actually come to what you would spend on a full retail price for brand new. So don't be afraid to get stuff on eBay, to buy used. Another thing is, once you get your what components you want to put into your PC build, go to pcpartpicker.com. You can actually enter every single component of it, and it'll tell you if you have any compatibility issues. It will also tell you how many watts of power you're going to need to power your unit. It's going to give you a lot of information, and if there are compatibility issues, it's going to tell you where it's at and what the problem is. So with building your own, like I said, you need to start with, do you want to go with AMD or do you want to go with Intel? Depending upon what kind of money you have, Intel is going to run you much higher prices. And to me, honestly, it was so confusing to go with Intel. Once I started watching videos, AMD was it hands down. It was very easy for me to make that choice. 10, 15 years ago, if you said AMD to me, I would have said crap. Everybody was saying crap at the time, but AMD in the past 10 years has really become a very close competitor and with Intel, and really given Intel a run for their money now. All of your AMD motherboards and CPUs come unlocked, so you can overclock them without a problem. There's no limitations on, other than the hardware limitations that you have of what you can do with that. With your Intel boards and processors, you're going to have to make sure that whatever process, if you want to overclock, you need to make sure that your processor is overclockable, that your motherboard is overclockable, that only certain processors will go with certain boards. And there's a lot of homework out there for you to do if you decide to go with Intel. Not trying to discourage you from going with Intel. Like I said, this is about my experience. So second, you need to figure out, what are you going to be using this thing for? Are you going to be using it for gaming, content creation, Is it going to be a workstation? Is it going to be a combination of all three? For me, it's kind of a combination. I do low-end videos, low-end content creation. I use it for school, streaming with school, or I'm sorry, video chat with school, and for work, and using it for my workstation for school and for work for what I need. Next, you want to look at whether you're going to go with ATX, mini ATX, micro ATX. That's going to be the size, the form factor that you're going to be going with your motherboard. This one here that we have right here today is an ATX motherboard. This is going to be a ATX mid tower case. They come much smaller than this, much smaller, and even bigger than this. So next, based upon whether you're using this for a workstation, creation, gaming, whatever, are you going to use an internal graphics built into the motherboard? Are you going to use a external graphics card? Are you going to get an actual graphics card to fit into your motherboard? Also, when shopping for a motherboard, you want to keep in mind what speeds of RAM that motherboard supports, whether it's 2133, 2666, 3000, 2400, 3200 megahertz. What speeds does your motherboard support? Now, I will tell you this, something I did not know. It took me forever to figure this out. I've been running this computer for about 5 months now at 2133 megahertz, because that is, no matter what speed that your RAM says that it's capable of, all RAM defaults at 2133 megahertz. You actually have to go into your BIOS and change that, which is something I didn't realize for a long time. So I wasn't even getting the full benefit of my 3200 RAM that we put into this. So, by the way, I should say, this computer has already been built. I've been using it for the past 6 to 7 months roughly, and now I'm doing an upgrade, or a couple of upgrades. I'm putting a new hard drive into it. We're taking a hard drive from my old laptop and putting it in as a secondary storage, and we're going to be putting in a new CPU fan. Since I am going to start doing some overclocking, the fan that came with the CPU is not strong enough for the overclocking capabilities of what the motherboard and the CPU have. So we're going to have to go with a new fan. In order to put this fan in, I've got to take my motherboard out. So I thought, what the hell? Let's make another video. Now, something you're going to hear time and time again is future-proof, future-proof, future-proof. And basically what that means is like building a house. When you build a house, you're building that foundation. And once you build that house, then later on down the line, as time goes by, you may remodel that kitchen. You may tear out that whole kitchen, put a new kitchen in. You may remodel your bathroom. You may update that bathroom, put new carpet in, get new furniture. This is kind of what you're doing, and that foundation is that motherboard right here. So when you're shopping for that motherboard, going back to that, you want to get the most up-to-date motherboard you can. You don't have to get the most expensive. That most expensive does not mean the best. Look for what you plan on putting on that motherboard, and deciding what you want to do with it, and then go from there as far as what features you're going to use on that motherboard. Don't get a bunch of crap on that motherboard that you're not going to need. You're going to see more of the high-end motherboards that are going to have on-off switches on them, little code, digital code readouts, separate CMOS button just for clearing the CMOS. You don't necessarily need all of that. You don't necessarily need 7 PCI Express slots. You don't necessarily need 4 RAM slots or 8 RAM slots. Decide what you're going to do with it and then go from there with it. Last thing for motherboards. If you do decide to go with a Intel motherboard and you do eventually want to do overclocking, make sure that your motherboard, the chipset model number, has a Z or an X in it. Anything other than a Z or an X, you are not going to be overclocking. They are locked motherboards. Next, we're going to talk about processors. The CPU. This is basically the heart of your computer, the brain of your computer, really. Now that you've decided whether you're going to go with AMD or Intel, you want to look at cores and threads now. Whenever a CPU refers to how many cores it has, that means how many chips it has on that CPU. The more chips it has, the more tasks that can be completed simultaneously. With threads, look at threads as the pathways or the roads to and from each chip. So each chip can have up to 2 pathways or 2 threads per chip, or core rather. So that's what, the more cores you have, the more tasks that can be completed, the more threads you have, the more efficiently each of those cores works. So here we are back to comparing Amazon to AMD to Intel. Amazon compares to nothing. Anyway, comparing Intel to AMD again. So like I said, on AMD, all of AMD's processors, CPUs are unlocked and available for overclocking. With Intel, only some of theirs are. You've got to be careful with which one you pick, comparable to your motherboard again. On Intel, in the serial numbers will include either a K or an X to be overclockable. Anything else is going to be locked, and you're not going to be able to make any adjustments on it. With an AMD Ryzen 3 series, you got 4 cores, 4 threads. That's kind of comparable to an Intel Core i5, and that's pretty much for simple gaming, simple workstation, looking to do schoolwork and stuff like that. That'll be more than sufficient for you. With the AMD Ryzen 5 series, they did have a 4 core 8 thread. I don't really see it out there anymore. The one we've got here is a 6 core 12 thread, the most common one on the Ryzen 5. It's pretty much comparable to the Intel Core i7, and that's more for high-end gaming, some game streaming, light content creation. An AMD Ryzen 7 series, 8 cores, 16 threads, is compatible to the Intel Core i9. Like I said, these are all comparable. There's things that the Intel chips are going to do better than the AMD. There's going to be things that the AMD does better than the Core series, Intel Core series. So on the Ryzen 7, the Intel Core i9, that's going to be more for your high-end content creation, your high-end streaming, 4K, 8K streaming, and content creation. You're definitely going to want a much higher-end processor for that. So the decision for most people, whether to go with AMD or Intel, is going to come down to this. AMD's products are going to be about 25 to 30% less than their Intel counterparts. Right now is the time of recording this video. Ryzen 7 CPU 3800X has a base clock of 3.9 gigahertz, overclockable to 4.5 gigahertz, 8 cores, 16 threads. It comes with a cooler, is $300. That is one of the best AMD Ryzen CPUs on the market right now. The counterpart is in Intel's Core i9, 9900K, base clock at 3.6 gigahertz, overclockable to 5.0 gigahertz, 8 cores, 16 threads. It does not come with a cooler. None of Intel's CPUs come with a cooler. So that is going to be an additional cost to whatever Intel CPU you go for. Your cheap coolers are going to be 30, 40 bucks. If you're going to be doing overclocking, you definitely want to invest a little bit more than that into a cooler. Now, one last price comparison I've got between AMD and Intel is that I looked on Micro Center's website this morning and looked at their bundle options that they've got going right now. And that's a bundle with the motherboard and the CPU. If you get them together, they'll give you a discount. On the AMD 7 3800X bundle is $390. $390. On the Core i9 9900K, that bundle is $705. Plus you have to buy another fan, so minimum another 40 bucks, $745 compared to $390. That is a lot more. It's a lot more. All right, so now that we're done talking about motherboards and CPUs, and I'm now done beating up on Intel, we're going to talk about RAM. So your RAM here, we're going to be going with the G.Skill Ripjaw 5. This is 2 sticks at 8 gigabyte DDR4, 3200 megahertz. And I don't have a whole lot to say about RAM. I'm one of the few. Go with what you like. Go with what you see. As far as brands and stuff, the biggest thing to know is what's going to be compatible with your motherboard. Don't get a motherboard that's only compatible to 2666 and then buy 3200 megahertz of RAM. You're not going to get the 3200 megahertz out of it. You're only going to get the 2666. The biggest thing I have to say about RAM is that, again, all RAM defaults to 2133 megahertz when you install it into your motherboard. You have to go into your BIOS to get that changed. That's going to be on your XMP settings in the BIOS. XMP stands for Extreme Memory Profile. And again, just if you don't know how to do that, if you can't find it, just go to YouTube and Google XMP or Extreme Memory Profile. There's plenty of guys out there showing you how to do it. One last thing, dual channel versus single channel. I do want to say that. Jay's 2 Cents actually has a fantastic video out there that finally takes care of the debate on going single channel or dual channel. Is it better to go with a single 16 gigabyte card or two 8 gigabyte cards to get your 16 gigabytes? And he has shown through and through that it is definitely better to go with two sticks of 8 gigabyte than it is to go with a single 16 gigabyte card. So let's move on to hard drives. Right here, I have got 4 different hard drives. One, two, three, and this little stick of gum is actually a hard drive, if you're not familiar with M.2 drives. All of these drives are a 1 terabyte drive. They all do the exact same thing. They hold the same amount of data. They store all your shit. However, how they work is very different. These two here are mechanical hard drives, which they work on a platter with an actuator and a read-write arm. They are mechanical hard drives, so they are very limited on how fast they can read and write, how fast they can process what you're wanting to do. So these two here are going to read and write at about 100 megabytes per second. This one here, this is a Crucial MX500. This is a Crucial MX500 in M.2 form. This here and this one are both SATA drives, serial ATA drives. There is one other one that I do not have, which is called an NVMe and sometimes an NAND SSD. Those ones there, well, first of all, these SATA SSDs, these here will both read and write speeds at about 530 and 500 respectively. An NVMe drive, which actually connects directly through your PCI Express lanes, can actually deliver, whether you're using a 2-lane or a 4-lane, can deliver anywhere from 17,000 to 35,000 megabytes per second, which is lightning fast. However, the reality in real-time viewing of it, the difference between the SATA SSD and a NVMe SSD in real time is going to be minimal. It's going to be a few seconds difference of load time, and I'm talking seriously, 2, 3, 4, 5 seconds difference in load times for your games, for your boot drives and everything like that. So these here are much more economical. Of course, these are the cheapest of the ones. These are kind of the mid-range as far as cost goes. And then your NVMEs are going to be your more expensive ones. That's your 970 Samsung 970 EVO. That's an NVMe drive with the lightning fast speeds. But like I said, the load times between that 970 EVO, which is around $200, versus this MX500 from Crucial, which I think I paid $80 for. It's just a few seconds difference for $100 in cost. So there you go for that. Moving on to GPUs, or graphic cards. This is probably going to be the single most expensive component of your PC build for most people. The biggest thing I have to say about graphic cards that I didn't see much on is that you want to make sure that you're matching your graphics card with your monitor. If you have the money for your PC build right now, but you don't have money to buy a new monitor, make sure that the graphics card that you buy will work with the monitor that you currently have, but will also work with the new monitor that you want to get. So on this one here, we use the Radeon RX 580. I wanted to use my 24-inch monitor that came with my Asus desktop until I had the money to upgrade and get a better monitor. So that's what on my 24-inch Asus, I've got a DVI-D port, which you're not going to find on most of your newer updated cards. So that was one of the factors of why I got this, why I ended up getting this card. but also it had some fantastic reviews, and even for a 3-year-old card, it's still holding up to what the competition has to hold. This is an 8 gigabyte card. I would definitely go with at least an 8 gigabyte card. 4 gigabytes 3-4 years ago, we're still doing well with games. If you're a big gamer, go with at least a 8 gigabyte graphics card. But this one here in particular, I had the DVI-D port, so I could use my old monitor for a little while. But I knew the monitor that I wanted to buy had a display port. This one here has 3 options. It's got the DVI-D, it's got 2 HDMI ports, and it's got 2 display ports. I'm sorry. So 2 display ports, which this display port is going to end up giving you the full function of your motherboard, CPU, and your RAM. Now with GPUs, you're going to have your choice between NVIDIA and AMD again. With AMD, again, we're coming back into matching it to your monitor. If you have a monitor already and it supports VSync or G-Sync, then you want to get the appropriate card to go with that, or you're going to lose the benefits of that VSync, G-Sync. FreeSync. VSync, yes. FreeSync on AMD. FreeSync on AMD and G-Sync on NVIDIA. That's to help eliminate your lagging, your screen tearing, and buffering between the difference in frame rates between your video card and your graphics card and your monitor. Now I would say whenever you're shopping for a graphics card, I would not now I'm talking retail prices. Buying one retail or even getting one used, the retail version of it, full price version of it, don't go less than $100. If you're going less than $100 in today's market, you are just wasting your money. You really are. Once you decide what GPU will fit into your budget, which one that you think you have picked, you don't know much about it, you want to figure out, go on YouTube and type in the model number, what it is, and review. And I'm telling you what, you're going to find more reviews than you ever wanted to find on every single component out there. And then go off of the reviews that you see. And if it's going to meet your needs and you like what you see, then go ahead and buy it. This is one of the things that I got off of eBay. I got this for $75 on eBay. This here, let me see, when this came out in 2017, it retailed for $170. And because of mining and folding, this thing actually went up to $650 in January of 2018. Even now today in 2020, the retail price on this is still $190. I got this on eBay for 75 bucks 6 months ago. It has worked absolutely fantastic, but I will say this. This here was a mining GPU, and with miners, how to tell if you're getting one from a miner. And you're going to hear people say, don't buy mining GPUs. They're crap. They've been worn out. They're overheated, this and that. Don't be afraid to buy one. A good miner wants their mining to be as productive as possible. So what they're going to do is they're going to run their video cards as efficiently as possible, as cool as possible, because the hotter they are, the less efficient they are. So they're going to want to run these things cool and clean so that they can get the most crypto out of them that they possibly can. So if you see somebody on eBay that's selling, the same seller has 4, 6, 8, 10 of these all up for sale at one time, that means they're upgrading their mining gear, their mining server. So they're trying to get rid of the old ones. They're going to upgrade. These are awesome buys. I could burn up 2.5 of these before I actually spent what I would spend on a brand new one. And like I said, for 6 months, it has been doing fantastic. Don't be scared. Next thing is our PSU, our power supply unit. There's 3 different kinds of power supply units. You have your fully modular, your semi-modular, and your non-modular. This one here, we've got the Corsair CX60 or 650M. That is a 650 watt power supply. The one we have here is a semi-modular, which basically means that your 24 pin and your 12 volt motherboard power supplies are going to become already connected to and permanent onto the power supply, but your peripherals will all be modular. Well, that's what modular stands for. Is that you will be able to pick and choose what power cords you're going to need to use in your system. A fully modular one, these two cords here will also be separate, so where you can actually add the right lengths to where these are some pretty long lengths, and I'm going to have to do some cable management to hide all of this stuff. Whereas with a fully modular one, you can actually buy your power cords to the length that you want them. And then we have the non-modular, which is what you see in my old Asus or your mom and dad's old HP or HP desktop, whereas you just got this bundle of ugly wires and you're stuck with whatever happens to be on this, and you better hope to God you don't need anything more than what this power supply can provide for. Now, as far as how many watts you should go with, that's another thing I love about the PCPartPicker.com is that it will tell you how many watts your system will require. And you want to go fit at least 50 to 100 watts over what that's asking for, so that you've got a little bit of wiggle room on there. Whenever one of your components fires up or speeds up, it's going to create a power surge, and just for a split second, it's going to draw more power. You want to make sure you've got a power supply in there that can handle that. My system is set for 438 watts, and that's why I went with the 650 and not a 500. I wanted some wiggle room, especially with the fan that we're going to be adding in there and the overclocking that I want to do. I wanted to be able to expand on that. And also, this power supply, retail right now is $130. I got this on eBay for $31 7 months ago, and I got a 2-year warranty through Square Trade for 7 years. So $38, and I'm 2 years, $7 for 2 years. So for $38, I got a used power supply with a 2-year warranty on it for less than 30% of what retail is. Another fantastic buy. Now, a couple other things I want to say about power supplies is that, well, whenever you're shopping for one that I did not see, again, I got lucky, is that whenever you're shopping for it, look for either continuous wattage or continuous plus peak wattage. If you see one that just says peak wattage, don't get it. Say it says a peak wattage of 600, 700, whatever. Its continuous wattage could be 200, 300. And you're going to have problems with that. So just stay away from something that only rates itself at peak wattage and not continuous wattage. Also, with the 80 plus sticker you're going to see on a lot of these, that's basically an efficiency rating. Basically what that's saying is that works at least 80% efficiency. And that has to do with the power that the energy that the PSU is drawing from the wall and how much it's actually using into the machine. So it's saying that it's at least 80% efficient, which is actually pretty good. Also, the bronze, silver, gold, and titanium, bronze being the lowest, titanium being the highest, each one has a higher level of efficiency. So your 80% bronze is going to be at minimum 80% efficient, and the titanium can actually be up to 92% efficient, I think. I'm sure you'll correct me in the comments if I'm wrong. So just keep those things in mind whenever you're shopping for your power supply. All right, now we have all the components that we want to get. We've decided what we're going to use. We checked our compatibility. We checked our wattage. We got our power. What are we going to put it in now? Case. The reason I'm putting the case last, and you're going to see a lot of people that will buy the case first and then buy everything to fit in that case. I want to pick out my components, and then I'm going to make sure that I get a case that everything's going to fit in, because you're going to see some motherboards out there, your mini ATX, your micro ATX, that are going to require much smaller cases than this. Your graphics cards. This one is a dual fan graphics card. You're going to have some out there, even a dual fan can be longer, it can be shorter. You're going to get some triple fan ones that are another fan length of this. So you want to make sure that you're getting a case that's going to take care of that's going to fit all your supplies. And whether you're going to go with air cooling versus water cooling, I'm not going to get into that. I don't need water cooling, don't know enough about it to speak about it. But if you're set on doing water cooling and having this cool looking water pump and everything glowing and everything, you want to make sure you're getting a case that is going to be sufficient to hold all your stuff. Make sure you've got room for cable management. This one here, this is the Deep Cool Matrix 50. I think I got it on eBay for $40, $41. I couldn't find it online anymore, but I did find a Matrix 55 on Newegg, which looks like it's just an upgraded version of this. It still has the side vents going down the sides, still has the, oh, there go the fingerprints, I'm sure now. Had it all nice and polished for y'all. But got the nice glass front, glass side. This is all tempered glass here. This is not plastic on here. It's got, I think about 7/8 of an inch of cable management room, which is quite enough. It's got 2 slots in the top for top ventilation, 3 in the front. You can either put 3 120s or 3 140s in the front, 2 140 or 120s in the side or on top, and then a 120 or 140 in the back on this particular case. It's got plenty of cable management room. You want to make sure you're going to have room for your drives. This one here has 2 3.5 or 2.5 inch bays, and then it's also got 4 2.5 inch bays that are attached onto the actual frame of the unit. You want to make sure you've got where your cable where the holes are punched out for your cables to go through. Make sure that that metal is turned, that isn't just cut out, stamped out, and you've got sharp edges there. Be very cautious of that. But pretty much find a case that you like. It's just to hold all your shit. It's like your gut. Find one that looks cool to you, that you like. Look for reviews on YouTube. Again, just like with video cards, just like with anything here, you're going to find millions of reviews, more reviews than you want. The only thing I'm worried about, or that bothers me, is that a lot of these cases now are having these solid fronts. And well, one, if you're old school like I was worried about not having a optical drive, DVD or CD drive. But I did find you can get an external one, USB 3.0, for like 20 bucks. So do that and have you a cool looking case versus having that big old play on front. However, this doesn't allow for any ventilation through that front. All that front ventilation is through these 2 sides here. And I'll tell you, just after 6 months use, this ventilation is clogged up quite a bit. I really had to blow a lot of air through these to get these unclogged and cleared out just after only 6 months use. What I'm probably going to end up doing is seeing about getting this plexiglass off of the front frame of this and actually making a screen front for this, so that I have a much better ventilation, especially now that I'm overclocking. So just make sure that whatever case that you get has proper ventilation. All right, last but not least, your monitor. You want to take this into consideration whenever you're buying. Most of your gaming monitors are going to be 24 inch or 27 inch. I thought that was too small. Looking at my old Asus 24 inch, it just looked so small for like gaming and anything. I wanted a bigger one. I ended up going with a 32 inch. Honestly, it's a little bit too big for gaming. If I would have known now what I would have known then, what I knew now, I would have went with a 27 inch max, to be honest with you, and gotten a higher grade of monitor. But you're going to see a lot of different letters with these monitors out there. You're going to see TN, VA, IPS, and PLS. Now your TN monitors they're going to be your most common. They're going to be the least expensive. The problem is you're going to have poor viewing angles, but they're going to be the ones that run at the higher hertz. The higher the hertz, the higher the frame rates. So most of your 120 to 144 hertz are going to be TN panels. But the problem is that the color quality is not going to be very good. They're going to look a little washed compared to your better panels. And also your viewing angles, looking off to the side, if you're not looking directly at it, they darken looking from side to side. Now your VA panels, they're similar to your TN. You're going to get your 120 and 140 megahertz out of them, higher frame rates. It's going to be a little bit better color quality, a little bit better viewing angles than what your TN panels are going to be, but you're still going to have the same drawbacks to them. Now you got your IPS, which are your premium panels. They've got great color, they got great viewing angles. You can look almost from side to side somebody standing off to the side from you and still be able to see what you're doing. So if you're looking for privacy, TN and VA are their way to go. But if you're looking to show off to your friends and that from sitting behind you, you want an IPS or a PLS screen here going on. But they got great color, great viewing angles. The problem is that the drawback is they're usually lower frame rates, lower megahertz. Most of your IPS and PLS screens are going to be 75 megahertz or less, which is going to be less frame rates. If you're not overclocking, that's not a big deal. I'll be honest with you, I still got a IPS screen. I spent about $200 on it. And it's a great screen. I play my games and get 60 frames per second out of it, no problem. And they look fantastic. So I'm not a online gamer, so I don't have to worry about being, worried about somebody coming around the corner and shooting me and me shooting them. Not seeing them before they see me. So I'm not that. I don't need that 120, 144 megahertz, at least not now. I'm still trying to get consistent with the mouse and keyboard. Being a gamer for all these years on consoles and that, this has been quite a trip changing over to keyboard and mouse. Okay, now your PLS panels, these are going to be they're going to be the absolute best viewing, best color quality, best viewing angles that you can get on anything. Again, you're kind of limited by the megahertz on it. You can get these in 120 and 144 megahertz, but they are ungodly expensive. These are the ones that are running $600, $700 to $1,000 for a 27 or a 32-inch monitor. They can get very, very, very expensive. All right, so here we are at the end of part 1 of this video series, and I just want to say thank you very much if you've actually stuck with this video through the whole thing. I really appreciate it. And part 2 will be actually putting this all together. So I will see you then. And everybody, let kindness be your sledgehammer.